Good morning, everybody. Thanks for joining us today, and welcome to HASS Connects, which is a series of conversations on transportation automation safety with leaders from throughout the transportation community. And this event is presented by the Highly Automated System Safety Center of Excellence based here in the USDOT Office of the Assistant Secretary for Research and Technology. And I'm Stephen Zoff. I'm the acting director of the HASS COE. And just as a reminder for everybody, April 15th through 19th this week is National Work Zone Awareness Week. And during this week and throughout the year, please remember that work zones are temporary, but actions behind the wheel can last forever. And as we mentioned in the chat a moment ago, please go ahead and introduce yourselves with the chat function, your name and your affiliation. And today's webinar is going to spotlight 3 transportation organizations that are deploying innovative technology or automation in their work zone operations to increase the safety for their workers. And we really look forward to the discussions today and hope that this event is just one of many ways that you'll engage with us throughout the year. So please join me in welcoming our moderator, Ashley Nyland, who is Acting Assistant Director of Program Development and Strategy here at the HASS COE. Ashley?
Great. Thank you, Stephen, and welcome everyone. Before we get to our State DOT panel, we have a very special keynote by Mark Curley. Mark is the Director of the Office of Transportation Operations at Federal Highway Administration, and Mark is going to share a few remarks to get us started today. Mark, I'll go ahead and pass it over to you. Thank you. All right, everyone. While Mark is getting his audio sorted out, I'm going to go ahead and actually introduce our panel. I do want to send a heartfelt thank you to all the panelists that are here today to provide to share with us practices that they're doing in their work zone. I absolutely empathize with where they are coming from and just really appreciate the wonderful work that they're bringing into their transportation system operations. So I'm going to present in order, do the biographies in the order that you'll hear the speakers today. So first will be Matt Miller. Matt is the Director of New and Emerging Transportation Technologies. He was formerly the E-Construction Program Manager with over 13 years at the Iowa Department of Transportation. Matt is a certified public manager from Drake University. He is the chair for Innovative Construction Technology Subcommittee of AASHTO on construction and a member of the Joint Subcommittee on Data Standardization, the JSTAN. Matt is also a U.S. Navy veteran who launched aircraft aboard the USS Theodore Roosevelt during Operation Enduring Freedom. Our second speaker will be Kelly Wells. Kelly Wells is a highway engineer with the North Carolina Department of Transportation and has over 30 years of experience. She currently manages the Traveler Information and Speed Data programs for the North Carolina DOT. Kelly co-chairs the Eastern Transportation Coalition's Traveler Information Program track. She previously worked for Federal Highway Administration and graduated from George Washington University. And our third speaker today will be Steve Hapala. Steve holds a degree in civil engineering technology and has more than 38 years with the Washington State Department of Transportation. 28 of those years specializing in temporary traffic control. As a work zone engineer, he's involved with the development of the agency's temporary traffic control policy and guidance documents, provides training and project support for agency employees, and is active with state and national work zone traffic control committees and conferences. So again, I want to thank this esteemed panel for all the wonderful work that they're doing every day to improve safety in the work zone. And I'm excited for you all to hear some of the innovative practices that they're using technology and automation to improve safety for their traveling public. Let's go ahead and we'll go to our first speaker. And when Mark does get the audio to work, we'll go ahead and have Mark chime in. But we did encourage our panel to wear orange today or high-vis green, as you see Matt Miller wearing today. Also encourage you all to wear that as well. So Matt, we'll go ahead and pass the screen over to you, and you have 10 minutes for the floor. Thank you.
All right. Thanks, everybody. So I'm Matt Miller. I'm with the Iowa DOT. I'm the Director of New and Emerging Transportation Technologies. I've worked in many roles through the department. I started as an inspector, worked my way up to a senior level inspector. I served as an auditor, a construction supervisor out of the Des Moines metro area. I then worked as the e-construction program administrator with focus on e-tickets and digital information. How does that apply to a digital as-built? I was the Navy veteran for Operation Enduring Freedom on the Theodore Roosevelt, and I'm a licensed drone pilot as well. So today I'm going to talk about just some brief topics with smart aero boards, e-ticketing, GIS mapping, 3D projects, drone LiDAR mapping, digital as-built, and technology pilots. So smart aero boards, this was, I was told I should probably mention this today. We started around 2020. We deployed the boards to feed Traffic Management Center and Waze. The aero board device feed is dependent on submitted requests to display on 511. So when we do, the inspection staff does their CARS request, the feed then is hooked to that request and then it displays on 511. There is no end of work zone identified, and there's a 30-foot accuracy on the devices themselves. So really it needs that request in order to be displayed properly to know which lanes it's closing in. So it's a way to try to use a device that's out in the field and deployed in a new and intelligent way. Let's see here. So the first thing is e-ticketing. And I think what's important to know on our e-tickets, we're using asphalt, concrete, and aggregates. We're getting 12 data fields on an HMA ticket, for example, and 21 data fields on a ready-mix concrete truck. But with an e-ticket, we actually find that we're capable of getting around 275 lines of data. So you can actually extrapolate a lot of information from that ticket itself. We use an application called EDOT. This is a Hall Hub product. So it's an application where you can see all of your tickets. You can scroll through and see how those materials are being delivered to the site. And with that information, we are tracking where the inspector is actually standing. And they've added a feature where they can identify work zones. So you can see here through the heat map, these are the locations where all of these tickets are being located each day. And we can go into that information. We can see things like pictures. We can see different components of that ticket. A feature that they have built in is a work zone to identify specific work zones. So the inspector basically draws where they're going and which direction. And with that, they can then toggle which sections of road is actually closed. And what happens is when that e-ticket is generated, the work zone data exchange request or device feed goes through, and it signifies that this is in fact an active work zone. We're able to delineate where the end of the work zone is basically through what that inspector has submitted. And it looks like this when it comes through on Waze. So you'll see that it's got a road construction. It's reported by a DOT project, and basically it gives you a beginning and an end. In this case, they had all of them toggled. So when that ticket was created, it actually toggled all of these work zones. So the inspector does need to toggle which ones are actively being used. With that information, we can then send it to Waze. Now this is different, of course, than what our CARS requests are. Like our CARS request, as an inspector, as somebody who's had to fill these out, you could say, I'm closing the right lane eastbound from here to here each day, or the option that many of us have is to say, okay, all the way from this end of the project to this end of the project, for the next 2 months, it's going to be alternating lane closures. So we're not really specifically saying where those lane closures are, just that they're going to pop up in those areas. So really, how do you get definitive information on where these lanes are closed for the traveling public, as well as any automated vehicles that could potentially go through? We have our, this is our pavement map, which identifies the different types of pavements that we have out there. And we can use this information to supplement. Right now, you might say 10 inches of concrete, 3 inches of asphalt. Well, I can actually tell specific information based on that ticket if I bring it through a web feature service layer. And when we put e-tickets into our Esri system, this is kind of what it looks like. It's really where that inspector's standing. So it's maybe less ideal in the fact that it's not maybe the specific placement, but it's much better than what we had before, which has basically been written on a piece of paper that goes into a shoebox somewhere. And we can see all sorts of information. We can see who received it, where it came from. So you're getting a lot of detailed information there. So we were one of 10 states that got an ADCMS grant, that's Advanced Digital Construction Systems. And what this does is this allows us to put the design information, at least this is the goal, is to put the design information from the CAD drawing into our GIS system and supplement it with all of our construction information. So we're hoping that this will actually bring us to the next level in that digital as-built. So just to give an idea of what a digital as-built kind of looks like, here, for example, is a Google Earth of an intersection that we were working on. We bring in the GeoTIFF from the drone imagery that is on the active project. We put in the design line work so we can actually see where the road is being built. And then we supplement it with all of the e-construction information that is collected. And that is to hopefully give an up-to-date, real-time assessment of like what's actually happening on the roadway. When we build a new lane, for example, how does that autonomous vehicle know that it's there? This is a way to try to streamline that process, which can kind of take a couple of years, depending on what the project is and how it's submitted and how it is manually entered into the system. So we want to automate that process. And we're using things like drones for photogrammetry. In this case, we can get a lot of measurement drawings. The one on the left is a drone imagery that was captured. It's like a 30-minute flight. You get a lot of detailed information. On the right side, this is actually done with a smartphone. So we're utilizing the devices that the inspectors actually have, and they can also get measurement information. We've done this with an IFC model as well, using a program called Propeller. So here's an example of a drone flight. You can actually see a picture that somebody took with their phone. We can bring in the IFC model, so now we can see where that new bridge is going. We can see the terrains, the station and offset for all of those locations. We can cut a cross section and see, for example, this bridge here, where the terrain is by design, where it actually is, and where that IFC model is going to be. And you can see those yellow tickets there are the e-tickets. And this is kind of an overhead view of all of these things kind of coming together to try to give better digital information as far as what we actually have out there for lanes and other things. We're looking at connecting the equipment itself as part of our ADCMS grant. We're partnered with Delaware, so we have a special provision, and we're capturing things like equipment ID, engine state, latitude, longitude, fuel percentage. This is some fairly basic information, but it can give us a lot of detail as far as those work zones. And we're going to hopefully use that to populate the work zone data exchange per the ISO specification. And we're going to connect OEMs through the e-ticketing provider to share to the work zone data exchange through that device feed. The traffic management center can then filter that based on the information that they might have from that construction office. And here's a QR code. I recommend you checking this out. If you scan that, it'll take you to the Delaware story map that they've created. They've actually already successfully done this with a paver and a roller, and you can see the inspector there as well. And this was actually taken real time. They flew a drone over it, and they were actually able to, with the timestamp of the drone flight and the workers, they were actually able to overlay this. So we also use another program called OnStation, and this is yet another tool where we put the alignment files, so we know where the project is, we know where the person is standing, they're pinging their location, and the inspector that might be using their smartphone is actually getting their location. So this is another way to use the information that we already have. And what they are also looking at is how do they feed into the work zone data exchange to identify projects that maybe don't have tickets. We're also working on some research projects with Virginia Tech and Intrans through Iowa State. And some of these projects are going to be a smart vest, worker warning system, which will actually notify the worker when they're close to a cone or if somebody has drove through those cones. We're also doing some things with the dynamic zipper merge system to test out signs that are actually providing a feed to connected vehicles, the work zone builder layout application, commercial vehicle work zone information system, and the automated truck mounted attenuator system. So you can kind of see here some of the different proof of concepts. We're actually having a meeting here in May to set up a couple of pilots for this research, and we're hoping that it will provide some good information for especially connected vehicles and definitely those automated vehicles as we start to see some deployments rolling out across the country. Here's an example of some of these dynamic merge systems. You have your 6 radar traffic sensors, 3 dynamic message signs, assign content based on the traffic information. And, these would be spaced out a couple miles in advance. Here's the example of the cones laid out and when the truck enters the work zone. and hopefully this is providing information to those workers so that they can be aware of things going on around them. There's an alarm that goes on the back of the hard hat that will actually ping if they were to step outside of the cones, and also identifies when those vehicles enter those cones. We also have the dynamic work zone. So this is, again, trying to put out that information to the vehicles behind it that might be connected to identify that this lane is being worked on. So really excited to try out some of these different projects. It's a multi-phase program. Phase 1 that we've already gotten through. We're now into phase 3. So this is the spring 24 section of the project. In Virginia, they're doing some testing, I think, next week is they're actually starting. So they're going to do a couple of weeks there in Virginia, and then they're going to come out to Iowa to test out some of these products.
All right. Well, thank you, Matt, for sharing what's going on at the state of Iowa. All right, our next speaker is Kelly Wells. So Kelly, you should be able to screen share and take it from here, and the floor is yours for the next 10 minutes. Thank you.
Okay. Good morning, everyone. Thanks for having me. I'm going to talk about a much less mature series of things here at NCDOT. We've begun to look at dash cams and how they might be useful in some traffic operations applications, one of which is work zones. And I'll also tell you a little bit about our SMART grant. So we have begun a relationship with Vision, who's a dash cam image provider. They have an exclusive partnership with one of the largest connected dash cam providers. They capture images every second from every active vehicle they're connected to. This gives us images every 100 feet or less. And the way we're going to interface with these images is through an integration with Iteris's ClearGuide software, which we use currently to analyze and visualize our INRIX speed data. So we started to think about, speaking of speed data, back in the mid-2000s, we didn't have traffic detection here in North Carolina on most of our freeways. So we used probe speed data to fill in a lot of the gaps. So this kind of led us to think, we don't have traffic cameras everywhere, and we aren't able to verify things that we have heard might be happening out on the road, but we can't actually verify because we have no camera. Maybe these dash cams can fill in some of those gaps. So I'm personally really excited. I think this is going to be a game changer. Like probe speed data was a game changer in the mid-2000s. I think this is going to be the next cool thing in traffic operations. It's not everywhere, and that's what you'll hear in my presentation, but you can see this is just a random day in January of how many dash cam images we would have access to in North Carolina. Privacy is an issue, of course, as that's what I get asked when I talk about this. So these are company-owned vehicles operated by company employees on company time, and Vision reviews the images to not have personal information be seen in the pictures. They're only available when the vehicles are moving, again, to protect people's identity, and they remain on the vehicle until they're actually requested from the software. So at one point, I thought it would be cool to have this data and be able to go back. But after I talked to our lawyers, we decided that we probably didn't want to go there. I get calls every week for people asking for traffic camera images, and we don't record. So if I had these images, I would be beholden to go back and get these images for the public. So since that's not a place we want to go, we decided to just have access to these images in real time. So again, it's really just verification of what we believe might be happening. So let's not go. Okay, so I'm going to tell you about 3 use cases. 2 of them aren't work zones, but I think you'll see the idea is that it's something we could use in work zones. So the first time we've been talking to Vision and talking to Iteris, and there was a brush fire in Western North Carolina in November of last year due to an overturned truck, and we were running dynamic message sign messages talking about low visibility. And so we were checking in with people on the scene, finding out when the smoke would clear, trying to be on top of when the smoke would clear so we could take down our DMS. So someone on our team said, hey, what about those dash cam images you've been talking about? Could we use those to see if the smoke is still out there? So Vision mobilized really quickly and fed us some dash cam images. And as you can see, there was still low visibility. So we were able to monitor the dash cam images to know exactly when visibility was restored, and we could take down our messaging about low visibility. So again, we knew something was happening. Visual confirmation was helpful. The next scenario is similar. We have a case in Western North Carolina on a relatively low volume road where there is there are issues of fog, but the crash history isn't enough to warrant a full-blown fog detection systems are very expensive. And so this place doesn't really warrant that. So we were asked, what low cost things could you do in traffic operations to help us with this fog issue? So we came up with this idea that we are a Waze Connected Cities partner. So we have access to the Waze alerts. So what if we listened to the Waze alerts, and when one came across for fog, what if we requested a corresponding dash cam image, and that would help us determine is there or is there not fog? And then once our thought was to do a sign with flashers potentially. Once we turned those flashers off, we could keep checking the dash cams and know when to take those signs down. So again, it's something's happening. How can we get our eyes on them? So we had, I think, pretty good success. The challenge is that only about 30% of the drives, 30% of the Waze alerts had a corresponding dash cam image. But of those, 88% were actually showing fog. So that part's good, but only 30% of the time we would be able to actually use this to say, yes, here's a Waze alert and here's a corresponding image. Now, work zones, what you really asked about. We see the same benefit in work zones. And just like Matt said, we have an existing manual work zone reporting system today. So our construction managers go into our website and log in their work zones. And exactly what he said, they can say, we're going to work from May to September. We're going to have intermittent lane closures. And it's hard to know on any given night, is the lane actually closed tonight? So that information goes to a lot of places, but sometimes it's vague in terms of the exact location and the exact times, exactly what Matt said. So we thought, well, can these dash cams be helpful in this use case? So we could verify the entries in our traveler information system, and then find any time where maybe the time or the location of a reported lane closure wasn't exactly right. And then we can activate our dynamic message signs and provide other traveler information more accurately. So we chose 4 high-profile work zones around the state, and we looked at 31 times where we knew there was something going on, either a crash in the work zone or the work zone lane closure itself. And again, in about 30% of those cases, we were actually able to verify that information using a dash cam image. So again, here's this 30% idea. But I remind myself all the time that when we went to probe data in like 2008, it wasn't perfect then either, right? But it's gotten better and we've gotten more and more confidence. And I really feel like this is something that's going to take that same path, that we'll be able to see the quality of the data get better and better as we go on. So where are we with this? We're hopeful that the dash cam images can help us have more situational awareness for verification for lots of different incident types. We found that, again, about 30% of the things that we looked for, we could find a corresponding dash cam image. So 30 is not great, but it's better than the 0 that we have today. And I really think that this is going to improve. And we're in the process of trying to do a procurement for this particular technology. I don't have a price. My brothers here on the webinar told me that their price they got was very expensive. I heard a price long ago of $10 an image, but that was a different vendor. So I'm not sure what the price is. I just asked Iteris this week, hey, by the way, remind me what the price is for this. So that might be something to consider. But again, I think this probe data was really expensive years ago too, and the prices have dropped. So the last thing I wanted to share was about our SMART grant, because it sort of builds on what I just talked about and a little bit on what Matt talked about. As I said, we have this anecdotal information about our work zones, and we want to make it better for, connected and autonomous vehicles, as well as just day-to-day people out there driving today in plain old vehicles. So we're doing 2 other projects. We're doing, like Matt said, we're transmitting our connected lane closure information 2 ways. That process is not perfect. We haven't really spent a lot of time digging into the quality of how we do that. So this is something I wanted to do more of. And then secondly, we give slowdown alerts using INRIX data through the DriveWise platform to commercial motor vehicles. So we're doing these 2 things in limited application. So we pitched an idea for a SMART grant, and we received one to make more of what we're already doing. So this would be on all freeways in our state, about 2,200 miles of freeways. And what we put out, and we're in the process of putting out an RFP for, is for hands-free, eyes-free automated alerts of freeway lane closures and freeway stopped and slowed traffic through Google, Apple, and Waze, right? Use the technologies that people are already using. So the RFP is in our purchasing group. As some of you know, this is an unknown amount of time it will take to go through this process. But hopefully it will go out this month, and we'll have our grant wrapped up by May of 2025. So I look forward to sharing the results with you after that. And back to you, Ashley.
Great. Thank you, Kelly. And I agree, 30% is better than zero. So great job down there in North Carolina. All right, we're going to go to our third speaker on the other coast of the United States. Steve, if you are on and ready, we can go ahead and you can share your screen.
Well, thanks for inviting me to speak here today. Excited to share what we're doing with work zones in Washington. So I'll start with something that's similar to what we were just talking about, what Kelly was just talking about. We're going with connected aerial boards on our project. So a little over a year ago, we implemented a specification on our interstate projects for aerial boards to be connected devices. And we've moved that now to all freeway projects, and it eventually is going to roll into our books, spec book. So we're requiring contractors on our highway projects to have these connected devices. So of course, with the Work Zone Data Initiative, developing Work Zone Data specification, more and more products are connected devices are available there. So we're just trying to get some of these out in our work zones. So you can see on our, let's see, where's the, so we show a little symbol on our traffic control plans as a Wi-Fi or a connected device. Most cases, it's just the contractor just going to retrofit their existing aerial boards, and similar, you're seeing Waze posts here. So this was actually a pilot we did with our maintenance work zone crew. You know, they had a lane closure, and we're getting those posts. Happens whether or not the operator, the aerial board, even knows it's going on, but just by activating their device. So I think we had 22 projects in 2023. Hopefully quite a few more projects this next coming year. And we're working toward getting other devices, connected devices into our work zones. But these ones are required now, at least for the last 2 years or a year and a half. And of course, the connected device data flow. So here's where we're at, trying to get WZDX compliant data devices. So aerial boards where we're starting with, getting those Waze, Google Maps feeds. We also have a translator going out to the National Registry. As of April 2023, we were under development with our specification, our data feed. Now it's live. So we've joined many other states here with data feeds going to the National Registry. So we're anxious to get some more devices out there in our work zones providing data feeds. One thing we've really clued on is queue warning systems. We've been finding in Washington, especially in our urban areas, that traffic volumes are getting high enough that our work windows where we can go out and do construction work and not cause any congestion is getting so small that it's causing constructability issues. So we know we're going to have to create more congestion to get our work done. So on a basic level, we've got specifications, contract specifications, and traffic control plans, typical traffic control plans developed for, in this case, nightly lane closures. When a contractor goes out and closes a lane, we'll have a couple advanced message boards leading into that work zone, and a couple roadside sensors, one at the traffic sensors at the lane closure taper, and another up in the beginning of the work zone. And then of course our connected aerial board providing those data feeds out to the public as they approach the work zone. So when the sensors pick up slow traffic, so the first sensor picks up some slow traffic at the lane closure taper. Well, if there's no delay, the first message board is blank. The second message board just talks about the upcoming lane closure. We start to pick up some delays at the taper, then we trigger that next message board, say left lane closed, 3 miles ahead, stopped or slow traffic, 1.5 miles. Now, if we get back up, so all the way back up to the beginning of the work zone, the second that triggers the next message, slower stop traffic, next 3 miles, and then we say use all open lanes, take turns at the merge. So trying to encourage drivers to zipper merge when we get congestion, use all those lanes as they get up to the lane closure taper. You see where people will move over early. You get that issue where an open lane all the way up to the closure. You get some road rage incidents, potentially drivers trying to block drivers from going around. So just trying to encourage zipper merging. So this is a system that can be installed, nightly lane closures. It's just a couple extra devices that we would normally use, our existing message boards, a couple roadside sensors. Our specification allows our traffic control supervisor, our traffic control subcontractor to do this work just using a third party's vendor's application. And those are all listed in our specification. And then we have a smart work zone system. So again, we have typical plans for this, special provisions, contract provisions for including this in contracts. And these would be more elaborate queue warning systems, so to speak. Longer duration, maybe we're closing lanes for 24 hours a day, a couple weeks at a time, and anticipating some pretty good backups. We implemented a system like this on I-5 south of Olympia between Vancouver and Olympia, where we had I-5 closed a single lane 24 hours a day, and then additional nightly lane closures for a bridge deck rehab or multiple bridge deck rehabs. And we anticipated up to 6 to 7 mile backups. And we got close to 9 mile backups at times. So we modified the system, expanded it, but we were able to provide real-time information about delays. So not just where the stops are, the delay times, and then again, more zipper merging messages as they approach the active work zone. We did put cameras on some of the message boards, so we were providing camera feeds back to our TMC because we didn't have cameras in the area. You know, and these systems can be really dynamic. You can have message boards anywhere in the state if you want to talk about a high impact closure. So doing a lot of training with our regions, trying to get them aware that these systems are out there, when they could apply, and get more of them in our projects. And actually on the I-5 project, we had closures for 2 weeks, backups up to 9 miles, depending on the time of the week. I went back and looked at the crash data for those 2 weeks, and all we had was 2 property damage only collisions, no injury collisions for those 2 weeks with backups up to 9 miles. Internally, washed out wise with our folks, our incident response program has actually outfitted 49 of our IR trucks with sequential flare devices that are along with connected technology, similar to WZDX feeds, providing information to ways, mapping systems, that type of thing. So of course, incident response incidents that are unplanned work zones. Maybe you just have, you have a vehicle out there, and we're trying to keep our incidents from becoming incidents themselves. So making those aware, everybody aware of those, I think that's great. We got 49 of our trucks outfitted. So I think that's pretty much every IR vehicle is set up with this technology. Just an example here of those devices in play. This was actually a construction emergency closure in a construction project. So our incident response team was out there. They deployed a couple sets, I think 2 or 3 sets of their flares. So besides the visual effect, you're getting the automation, the information out to the Google Maps ways, all of that about the closure. Our maintenance side of things, struggling a little bit with getting some of this in maintenance. We've been piloting some devices in maintenance, easier to do that way, but to get them, construction projects, we found it's been a little easier. We have a specification, we ask our contractors to provide them, and we're getting what we want. But the maintenance side of things, because maintenance, unplanned, often activities can make a challenge for having devices available. But we don't have purchase contracts for these devices, so we're buying off the shelf things, different crews buying different equipment. So a little bit of an issue there. And then data service fees, how to manage those, because you got all these connected devices, and there's data service fees or data fees that go along with that. So we're struggling a little bit with that, but we are doing some in the maintenance side of things as well too. We have what we call maintenance accountability program, MAPS teams. These are basically maintenance survey crews that go out, and they've been using some connected devices. So just dropping a PIN device out there, same thing, providing those data feeds, that there's a crew out there, a survey crew out there doing work along the roadway. Getting good anecdotal results. The crews feel like the public is more aware that they're out there, they're moving over sooner, they're slowing down. We've heard from some drivers that they're catching the notifications and seeing the workers, aware of the workers being present. So, good feedback. The crews are pretty happy to have these devices. So we've been piloting these and looking to do more of it. Another side benefit we're getting from those devices, in this case, they're actually getting time spent. So for planning, how long they're spending at each location, getting that data off of those devices when they activate them and deactivate them. So a little side benefit there for getting some more information for the work crews. And then lastly, I want to talk about our automated speed enforcement at work zones. So we're working toward that in Washington. I'm borrowing some slides here from Kyle Miller. He's our program manager for the automated enforcement program. So just due to the pandemic, we've been seeing lots of erratic traffic, lighter traffic during non-peak hours, excessive speeding, erratic driving, including over 100 mile per hour speeding. Several counties have seen a 10% increase in traffic speeds pre-pandemic compared to in the pandemic or now. Average at 12% higher in our 3 largest counties, so King, Pierce, and Snohomish County, 12% higher speeds on a daily basis. So just a lot of speeding, 13 vehicle or collisions in 2022. 242 crashes contributed to high speed alone. And of course, our work crews and our maintenance crews are just seeing more close calls, more high speed incidents. And actually this year so far, we've had 2 serious collisions in our work zones, sending 9 of our maintenance crews to the hospital to be checked out. from work zone collisions related to speed. So it's something that we've been really, trying to get a handle on. So actually, we proposed agency legislation in conjunction with the industry, labor's union, for speed safety cameras. And actually in 2023, the bill passed unanimously. In this last session, we updated the program, and now we have an RCW revised code of Washington allowing automated speed zone or work zone enforcement in active work zones. So we're hoping to deploy that early next year. We've been working with other states on their best practices for these systems. So I think we're going to have a pretty good program set up when we get going. And this is the governor signing our bill last year at our work zone memorial event that we hold every year during work zone awareness. So it's going to have to be active work zones, and I bumped through the slides. So we're going to have workers present. So there has to be workers present. We're going to add signs. So we have to sign that there's going to be work zone speed limit photo enforced. So we need to have the signs up there. Where there's available, we're going to use our speed radar cameras. We've been using the speed display signs in a lot of our work zones. So our bill does say when feasible, we need to provide these feedbacks as well. So letting the driver know that it's photo enforced, showing what the current speed is, telling them what their speed is. After that, then they can encounter the enforcement vehicle, which will be a marked vehicle in the work zone. We plan to move these around all over the place. Seattle, Spokane, Vancouver, all over the state. We're going to try to cover the state as much as we can, get this awareness out there, get the citations out there. So the system will collect a series of images. It's going to collect, worker present, time of day, location, posted speed, vehicle speed, license plate, and the registered driver's information. And then all that imagery will be checked out and transmitted to our state patrol. So this is what Pennsylvania, similar citation. This is similar to what ours will look like. So our WSP will review the information, verify that it's correct, that an infraction is incurred, and then an infraction will be mailed. So there'll be an adjudication process, and these speed safety camera violations do not become part of the registered driver's record. So they are an infraction, but they don't go on the driver's record. So just closing things up here, this is where we're at now. We're at the RFP to get a vendor on board, so we can hopefully implement this early July or early 2025. So this is just our process. Kind of gone through that already. So we're in the vendor selection process. We're hoping to get this going early in the following year. I think that's all I have.
Great. Thank you, Steve. It was wonderful to hear from Washington State DOT. And I would like to cue everyone to put your questions in the chat. As you know, you're all muted, but we would like to have, we do have some time here for some discussion with all of our panelists. And you should see that there are numerous folks from the U.S. Department of Transportation, Operating Administrations, Federal Highway, NHTSA, FTA, FMCSA, and of course Volpe, all of which have played a vital role in work zone safety. Many of you have engaged, of course, with Federal Highway, but also with Volpe on the WZDX efforts. So kudos to the team event here and the teamwork here. So please go ahead and start populating your questions in the chat, and we will go ahead and moderate those. Great. While we're waiting for those questions to come in, we have teed up a few on our side. So I'll go ahead and kick us off here, and please, again, put your questions in the chat. This is open to all the panelists, but please go ahead and respond. What additional research do you believe would benefit the concepts that you've presented today, or in general when it comes to innovative technology integration into your work zones? So please go ahead and come on screen and feel free to answer that question.
Can you say the question again, Ashley?
Yes, of course. So what additional research would benefit some of the concepts that you presented today in the innovative technology integration of work zones? So what research or piloting would help you deploy work zones or more robustly in your operations?
Yeah, I think for us, it's obviously partnering with industry to find out the solution. We tend to try to follow the KISS method wherever possible, right? Keep it simple. The fact is, most people have some sort of smartphone device. Let's take advantage of that data where we can, and let's figure out how to streamline that information into a way that makes sense for everybody, and do away with the generic lane closure from here to here, and really start to pinpoint where we need to look at. And when we identify these work zones, it can start as simple for automated vehicles as rerouting, route around the construction. Maybe we don't worry about driving through the construction yet until we have this figured out a little better. We've done some pilots with like companies like Pilot that do smart cones that try to give information as far as how the transition in lane closures is going. So some of those tools could definitely be helpful. But I think as we navigate how an autonomous vehicle might see a construction zone versus how we do, I mean, we know when we grind up those pavement markings that some of like even the ADAS systems might still see that as a pavement marking. So, if you can inform that information through the connected work zone, maybe the autonomous vehicle can now intelligently know that it needs to just ignore that. And I feel like that's where we're trying to get.
Thank you, Matt. Kelly or Steve?
Can I go a little off topic, but it's my burning issue, yeah, only because we've had this happen twice in the last 2 days, so it's top of mind. A little bit based on what Matt had said, trucks is our kind of big issue right now. And we've had 2 cases lately where we've had closures due to work zones. One was we're closing a bridge in Wilmington, and another we had a rock slide in Western North Carolina. And in all these cases, truck routing has just been difficult. And so I would love to see someone, we would be happy to participate if someone wants to tackle this whole issue about how we route trucks around work zones and get the best information to trucks, because we know how to do that with Google, Apple, and Waze, but that isn't what trucks need to be using. And so the issues about routing trucks around work zones, like Matt said, don't wait till they get in the work zone, tell them well ahead. How do we get this information to trucks? It's just one of those areas that comes up over and over and over again, and I can't quite find traction to get something going to make this better. So that's my plea for research or something.
And Steve, anything you want to add in here?
No, I guess for us, we're starting with the aero boards, but other devices. What everything's coming with connected technology, or seems to be more and more. But whether we end of work zone markers, just any other devices, what's the benefit? Having everything connected seemed to me it could be overloaded. So what's the benefit? What's the best products to? How do you start a work zone, you end a work zone? That's what I'm thinking about.
Okay. Great, thank you. All right, well, we'll take another question while we are waiting for Mark. It looks like, and Kelly did just mention that, can the panelists speak or talk to anything being done specifically for commercial motor vehicles? Matt or Steve, anything you'd like to add that's going on in your states and regions?
Yeah, I mean, for commercial motor vehicles, I know truck parking is kind of a big deal. Like, how do you identify those parking areas? And we've done that through various cameras and radars and other things. To me, as I think about it, and kind of like some of the experiments that we've had with e-ticketing, where we put a camera on a paver and we were getting a snapshot of that load being delivered. When we talked to the vendor, the best we could ever hope for was about 92% capture. So that was the best we could actually hope for, was to get that sort of capture rate off a camera. And obviously during snowstorms and other events, a camera can be kind of tricky to identify those things. So, how can you use data that's already there in an effective way? And I know one thing that I'm looking at in particular is the ELD mandate, right? Truckers are actually dispositioning when they're in a parked status. There's actually a code there. So would it be possible to get geolocation of when they're in a parked status to identify with geofence locations of parking availability? I think that's something that is worth a look. It allows things to move at scale where we don't have to deploy huge infrastructure spending to try to get that information more effectively to those truck drivers. And Kelly brought it up earlier, like Google Maps. A lot of truck drivers are using Google Maps. They're not using their commercial vehicle software to tell them where to go. And Google Maps doesn't tell a commercial vehicle that this is a good route. We had a snowstorm recently, and there was trucks that were getting stuck on level B roads they should have not ever went to, but those were the directions that they were given because, you know, Google can't differentiate a heavy truck versus a light vehicle the way it does with a bicyclist or a pedestrian. So, you know, is there a way to share that information with Google, like the width restrictions, the embargoed routes, to say, this is a safe route for a commercial vehicle to go, so we don't get in this situation? You know, obviously that would involve a huge involvement between our industry and somebody like Google to provide them with up-to-date maps that are effective. So there's several items out there, and how to best use the data. I actually tell people a lot of times my job is really, how do I get the data that people need to the people who need it, and just being able to communicate with people. That's pretty much what I do. So that's at least my perspective.
Great, thank you. And Steve, anything you'd like to add before we go to close?
No, in commercial vehicles is a big thing for our Q warning systems. We've got a major project on I-90 Vantage at Columbia River, a downgrade, pretty good downgrade coming into that bridge, and we expect Q. We're going to have all the traffic move to one side of the bridge, a lane in each direction, and the speed limit down to 40 miles per hour. So we're expecting great, queuing coming down this grade. So we're trying to catch the trucks at the top of the grade, get the information out to them where the slowdowns are, so they're not encountering a queue halfway down the grade. And I agree with Matt's about the detour routes. Trucks detour, Google Maps sends them on a detour route. There's restrictions there. That can be a big issue for us too. We've had issues with that. So definitely would, some work there would help us as well.
Great. Thank you. And thank you to the audience members for your questions in the chat. We will go ahead and moderate those offline so that you can get those answered by our panelists here, and we will share all the materials. We do want to spend a few minutes to let Federal Highway Administration close out, since this is National Awareness Work Zone Awareness Week, and they support all the state and locals along with the other operating administrations. So Mark Curley or David Johnson, one of you, if you could come on and give a few remarks to close us out, that would be wonderful.
Okay, well, sorry about all that. And yes, I'll make it very quick, some abbreviated remarks. We're so happy to be part of this presentation, and I want to thank all the folks for putting up with me. The speakers are fabulous, absolutely fabulous. And in the prep with the speakers, I'm so glad to hear things like the work zone data exchange mentioned, and all the automation and all the technology that's being used. I was really incredibly impressed. As a matter of fact, I was having a call with someone else this morning, and I mentioned that some really top-notch stuff is being done throughout the country in this area. So I am going to really streamline my remarks, as I know I've blown so much of your time. So just welcome to National Work Zone Awareness Week. This is the 24th year of Work Zone Awareness Week. So kudos. Hopefully we got many, many more to come. Slide 4. I won't talk a lot about the trends, but if you look at the numbers here, the fatalities and injuries, they're not getting any better, even though the numbers only go through 2021 on these graphs. The 2022 numbers, the fatalities are slightly lower, but the overall trends remain. Still a lot of work to be done. And the physical infrastructure didn't become 25% more dangerous between 2012 and 2021, nor did the way we design work zones. These trends therefore demonstrate the influence of behavior and an increasing prevalence of poor choices that led to steady rise in fatalities. We're at the point of diminishing returns using physical infrastructure to address safety issues. The past 10 years have seen increasing pivot to new strategies, tools, emerging technologies like automation, as I mentioned earlier. And I was so impressed by the 3 speakers, and I think we probably could have had a large number of state DOT speakers on board. So next slide. The US DOT's National Roadway Safety Strategy, the element on safer roads, that hits on work zones right there. It calls out the work zone data exchange, design roadway environments to mitigate human mistakes and account for injury tolerances to encourage safer behaviors and to facilitate safe travel by most vulnerable users, our most vulnerable users. So if you're not familiar with the proven safety countermeasures, there's a link given there for connection to the National Roadway Safety Strategy. Go to the next slide. got a summary report that we put out, the identification of national work zone safety objectives and activities. If you're not familiar with it, the report represents 11 specific strategic objectives to enhance work zone safety nationally. There's a link there, so if you're not familiar with it, take a look at it. Next one, the work zone data exchange. Like I said, I'm so happy to hear the mention of that while we're prepping for this call by these states. And, you know, I refer to the orange states when we talk about this map in the office, and it's picked up so much visibility, even within US DOT and federal highways, and trying to look at things from you know, the connectivity from border to border, coast to coast. How close are we? How many states are orange, but maybe they only have one application in the state? You know, what could be done to get statewide applications, corridor-wide applications? Where might we have, you know, some work with corridors? I-35 looks like there's a number of states that you have some connectivity there. The I-95 Eastern Transportation Coalition states, it looks like there'd be a lot of connections there. So a 5-year goal, could we get significant national coverage? So if you're not aware of the work zone data exchange, reach out to, you know, the folks on our work zone team, and please try to learn more about it. I think it's really cool, and I think it's going to make a big difference, both for the near-term operational needs of DOTs and the long-term needs of automated driving systems and other technologies and automation in the future. Next slide. MDODE, managing disruptions to operations, the data exchange. This is built upon the work zone data exchange to manage other types of operational disruptions, such as road weather, crashes, emergency operations. MDO objectives will create a structure for taking in operational event data from a variety of sources and making it accessible to users through a common platform. So a lot to come in this area. We're really excited about moving forward with this. There's a lot of good stuff that could come in this particular area. And since I blew so much time in the beginning, I ran through those so quickly, but there's some contact information on our work zone program if you're interested in that, and the work zone clearinghouse, all kinds of good information from training and best practices and stuff like that, all very much available in our smart work zones link as well. So thanks again for glitches on my part, and Federal Highways is very, very, very happy to be part of this. And those were great speakers that I was able to share time with.
Mark, thank you so much for joining us today. I think this has been really just a fantastic and thought-provoking conversation. I also think it's just so exciting to see this collaboration between state agencies, the federal government, the private sector, all working together in the interest of advancing worker safety. And so much to thank you for. Kelly, Mark, Matt, Steve, and especially Ashley, our moderator today. Thank you so much, and look forward to joining you soon.